Hello everyone and welcome to Malware Development in Go Lecture 1. In this lecture, I'll be talking about the mindset of a Whitehat. First of all, I would like to thank you for buying this course, and I really hope you enjoy it and learn as much as possible from it. So without further delay, let's get started. First, let's talk about the end goal of this course. In this course, you will learn how to bypass Windows Defender by creating a shellcode loader. And you will do that in Go. As you can see, this goal is pretty straightforward. Later in the course, I will explain what is a shellcode, what is a loader, and how you can do the creation of a shellcode loader in Go. What I would like to talk about next is why I chose Go for this course and why Go is an adequate language for creating malwares. First and most important point for me is that Go is an easy language to learn. The syntax is very simple, unlike other languages like Rust or some very advanced C++. Go is considered to be the commoner language. Anyone, even without the need to have very sharp programming skills, can learn Go. And to do that, it's actually pretty easy. You go to this link and you will have like a Go tour, which is free, of course. And it will take you about 1 hour to complete. And after that, you will be ready to create Go code that is ready to be used in production. This is the first point. The second point is Go generates statically linked binaries. So what does that mean? That imagine you write your Go code, you compile, you get a binary. This binary for Windows is the .exe format, for instance. So this binary that you will get after compiling with Go, you can put it on any machine that you want, and it will run like a standalone. Meaning you don't need to have any dependency, you don't need to have any C runtime, you don't need to have any pre-installed DLL. You just put it on a machine, even if the machine does not have Go, and it will run. Like for instance with Python. With Python, you create your Python script, and to run the script on a new machine, for instance, you need that new machine to have Python installed. Otherwise, the script won't run, unless, of course, you compile it with PyInstaller and stuff like that. This is the second point. The third point is that Go is very easily cross-compilable. Meaning, imagine you are working on Linux or macOS, and you want to create Windows executable. With Go, it is actually very easy, as we will see later in the course. While, for instance, with C++, you will need to have the toolchain installed or use some stuff like MinJW and stuff like that. With Go, everything works by design, and the language is actually designed to solve the problems that are seen in another language. So now that I said why I chose Go for this, I would like to talk about the mindset to have while following this course so you can learn as much as possible from it. 2 golden rules. The first one is be curious, read a lot. Whenever there is something that works, ask yourself why it works, and if it does not work, also ask yourself why it does not work. Always seek to learn more, which is a mindset to have not only in malware development, but in all your cybersecurity journey. The second golden rule I would like to talk about is that understand that out there's someone better than you. This is like the humble approach to have if you want to learn from everyone, and always remember that each one that you encounter in your cybersecurity journey has something to give you, has something to teach you. Either he will teach you something new, or he will teach you something not to do. So keep in mind that being humble is really key in cybersecurity, especially in malware development. Last point I would like to talk about in this introduction is please remember the white hat. We are not black hat people, we are white hat people. We are not malicious. We, of course, seek offensive security knowledge, but the end goal is to have better security, to better defend against the threats out there. As an anecdote, I put that with great power, there is great responsibility. So please act responsible and don't choose what you will learn in this course to hack, for example, your friend or girlfriend. Rather use them in real legal engagement for security companies that will bring benefits to them. So thank you for listening to this, and please enjoy the rest of the course. Hello again, everyone, and welcome to Malware Development with Go Lecture 2. In this lecture, I'll be presenting the courses lab. So let's get started. So what you will need for this course, if you want to follow the same step that I will be doing, are first, a Windows operating system. Second, a Linux operating system. For instance, as you will see later, I'm using Kali because it just comes with all the things that are already installed. But of course, if you have another Linux, you can use anything else that you want. Why you will need these two and not just one OS? First, you will need the Windows to test the malware that you will make. Because at some point, when we develop the Go malware, as I said, the end goal is to bypass Defender. You will need to test that the malware is functional. It does what it is expected to do, and that Defender is happy and is not killing your malware. So this is why you need first to have a Windows operating system. You will also need to have a Linux operating system to actually write the malware. We don't write the malware on the same machine on which we test because there is a possibility that Defender will detect you along the way while you are writing the code, and it will delete your code midway, which will be a real pain if you want to develop without being interrupted each time by Windows Defender. So how to have multiple operating system on the same machine? In my case, I will present my personal lab, but of course you can choose whatever you want. For instance, my host, which I'm using now for the presentation, is an Arch Linux. On this Arch Linux, I installed VirtualBox. For those who are not familiar with VirtualBox is an application you install that will let you run virtual machines. For instance, in my case, on my host I have two guests virtual machine. The first one is a Windows 10. The second one is a Kali Linux. On the VirtualBox panel, you will see that I have one isolated machine that is out of scope for this course, and I have one Windows 10 virtual machine that I use to test my malwares, and I have a dev virtual machine, which is the Kali Linux that I use for development. In real life, what it will look like is something like this. This is the Kali Linux. This is the Windows. Everything is running on the same machine. And this is how I can use both. This is my setup, but of course, as I said, you can use whatever you want. Some examples, you can use Windows host, and if you are familiar with Docker, which is another virtualization technology and isolation technology, you can use Docker containers with a Kali Linux container to make the development. You can, of course, also just use Windows for development and testing. It is possible, like technically you can disable Defender, develop, and then enable Defender, but I actually don't recommend it. It is best practice to actually separate the testing from the development. I use VirtualBox, but again, there's a lot of technologies that does the same things that VirtualBox do. For example, you can use VMware, you can use KVM, which is open source. I use VirtualBox because I'm just familiar with it. So I am on a Linux as a host, but of course you can use Windows as a host. You can even use macOS as a host to develop your malware. So the possibilities are endless. I really advise you to when you want to set up your lab, to always check the official website. For instance, in my case, to install VirtualBox on Arch Linux, I followed the instructions that are on virtualbox.org. They have instructions for each OS. For example, if you are on Mac, if you want to install VirtualBox to spawn a Windows VM, you can use you will use different instructions than if you are on Windows than if you are on Linux. Then when you have VirtualBox, you will go to kali.org and you will install the VirtualBox image from the Kali official website. That's how you will get a Kali virtual machine. And then if when you want to run the Windows virtual machine, you will need to install the ISO file. And to get that, you will need to go to Microsoft official website. The point from this slide is that always use official websites and don't use third-party website because it may contain viruses and malicious stuff. So we want to avoid that. That's why we always check the domain name, then we are installing from trusted source. So this was it for this quick presentation about the lab. I really hope you will take your time and choose the lab that will make you the most comfortable when developing and testing your malware. So thank you, and please enjoy the rest of the course. Hello again everyone, and welcome to Malware Development with Go Lecture 3. So in this lecture, I'll be giving some notes on installing Go inside Kali Linux. So let's get started. So first of all, and the most important thing I would like to talk about is the Go version. So by default, with some Kali VirtualBox's image, Go is already there. However, the version is a little bit too old. So I really advise you to check the Go version that you will be using. For instance, for this course, I'll be using the Go version 1.23.1 for Linux, the stable version, of course. So to install Go, there is not a lot of ways. There is only the official way, which is to go to the official Go website and see the installation documentation. And depending on your operating system, you will get the most updated version just by following the instruction given by the Go team. So let's go check this website together. So here I am in my virtual Kali Linux machine, and I went to this official website, and as you can see, I am presented with a specific set of instructions to follow, depending if I am on Windows or Mac. In my case, it's Kali Linux, so I'll be using the Linux tab. And to download the actual Go, you just click on download. You'll be presented with the feature download tab, and you choose whatever you want. For example, for Microsoft Windows, if you decided to develop your malware on Windows, you will be presented with an MSI file. For Mac, it's a package, and for Linux, it's a tar.jz. And of course, for the source version, you don't need to install it unless you, of course, want to compile Go from source. I really advise you to download the latest Go version. I am working with 1.23.1 and it's doing fine. So anything after Go 1.23 would be fine. Some additional notes. You only need to install Go, the machine you will develop your malware on. In my case, it is Kali Linux. You don't need Go on the victim machine, which is where lies the whole power of Go, because it's a standalone binary, as I said in the introduction lecture. Small note, if you decide to install Go on Windows, and if you have some specific antivirus, some antiviruses don't like the Go installer for some reason, so you need to do some whitelisting, I think. So don't be afraid if your antivirus start doing some alerts when you install the Go installer. You're installing it from the official website, so it should be free of any virus. Even if your antivirus or Windows Defender might flag the Go installer for some new Go version, be assured that the Go compiled malware will be accepted happily by the antiviruses and will not be flagged. You will see later on the course. Another interesting point is that I really recommend you install your favorite IDE in the machine along with Go, because at the end we will develop some code and having an IDE will be very interesting. In my case, I use NeoVim, which is a like an IDE inside the terminal because I don't like getting out of the terminal a lot. But you can install whatever you want, for example, VS Code or any JetBrains IDE if you like it. So that was it for this lecture. So thank you for listening and enjoy the rest. Hello again, everyone, and welcome to Malware Development with Go, Lecture 4. In this lecture, we'll see Windows Defender actually defending against some well-known malwares and threats. So let's get started. First, I would like to talk about the fact that Windows Defender was considered a joke in the past by the security community and by normal users. This is mainly due to the fact that it did not actually protect your PC and had a lot of false positive, meaning it will detect non-malicious files as being viruses and start raising alerts on your PC. That was in the past, but Windows Defender today is not like Windows Defender yesterday, meaning it has gotten a lot better over the years. Today, we cannot say Windows Defender is a joke like it was, and it actually can block threats and defend your PC in real life. So it will really block you during red teams if you are not prepared against it. A very important note is that Windows Defender is for free by default with Windows licenses, meaning that a lot of companies on the world will have Windows Defender even if they don't have budget for security. So there's high chances that you will encounter Windows Defender in real life. To see that Windows Defender can actually protect, let's take two well-known malicious software and test them against Windows Defender. For that, let's go to our Kali VM. So on my Kali VM, I have two malicious software. One is called simpleexec.exe, the other one is called rubius.exe. So let's start talking about simpleexec.exe. So how I got simpleexec.exe is through MSF Venom. You will see in this course, we will talk later about MSF Venom. But what you need to understand at this point is that simpleexec.exe will just run calculator in a malicious way. But at the end of the day, it will just run the calculator app on Windows. It's just the way that they do it that is malicious, which is why it is considered as a malicious software, as we will see later. The other one is rubius.exe. So Rubius is actually a very famous tool made by Ghostpack, and it is used by red teamers and I think malicious people to interact with the Kerberos and abuse it. So Kerberos protocol is outside of this course scope, but it's very interesting for you to know that this exists and is open source. So you have the code for it. It is made in C#. To get it the official way, you just have to go to the release and download the source code and compile it using, I think, Visual Studio. But if you don't have Visual Studio on your Windows machine, I have an already compiled version in which is a fork of Rubius. It is in the Exploration Batcave organization. You just go here. I added some GitHub actions to build automatically the C# project, and in Exploration Batcave Rubius, you see it is forked from Ghostpack Rubius. You go to the release, and you will have the two source code like in the official one, but you will also find this rubius.zip that you can download. You will have the rubius.exe as I have it here. So we have these two files. Before going to the Windows machine and see how Windows Defender will react to these two files, what I'd like to show you is VirusTotal. So VirusTotal is actually a very interesting project made by Google, where you can choose a file, upload it, and it will be scanned by a lot of antiviruses without the need to buy them all. So let's try, for instance, to upload our simple exec.exe. So you see, it has been scanned by all these security softwares, including, for example, Bitdefender. Avast should be here for people who know Avast. Microsoft Defender itself, which says that it is detected as malicious. I think there's some EDRs here. Maybe Sentinel-1 should be somewhere here. Google also, Google AV. So as you can see, a lot of security solution detected this as malicious, which is normal. We can do the same if you want with Rubius.exe, and it should also be detected by a lot of security solutions. A small point about VirtualAlloc. So don't upload your personal files, because as you can see here, people can make an account, and if you pay Google, you will be able to download the sample uploaded by other people. This is the first point. The second point, if you want to develop your malware and use it in real life, in real engagements, don't also upload it to VirtualAlloc to check if it is detected, because blue teamers will be able to download your malware and analyze it by hand on their own and create some IOCs for it and some detection rules, making your malware detectable in the future. So just use VirusTotal for educational purposes and for some testing, like very light testing, okay? So now that we saw that Rubius.exe and simple exec.exe are malicious, let's transfer them to our Windows VM and see if Windows Defender will block us. And to do the transfer, I won't transfer them as they are here. I will just transform them to a zip file, and these two zip files are password protected. If you don't put a password, the zip file itself will be malicious, but when you put the password, the zip file won't be malicious because it is encrypted actually. So I have these two. Let's go to the Windows VM. So here they are. Okay. First of all, before starting doing tests on your Windows, what you should do is go to Windows Security in your settings, go to Virus and Threat Protection. You can see, go to Manage Settings, and here you will need to turn off these two here. These two options. So what these two options will do, so the most important one is automatic sample submission, meaning that if some malicious files are detected on your PC, what Microsoft will do is take the file and send it to their own threat intelligence without your permission. So what we'll do is turn that off, so our malware won't be sent to Microsoft. But as you can see, the real-time protection is still on, meaning Defender is still active. What I will do is I will take for example, the simple exec, which is password protected. I will unzip it. Extract all. Extract it here. And as you can see, Windows Defender said directly that there's a threat, and I'm sure it won't let me even execute the file. So here I open PowerShell. I am on my desktop. I will try to execute the file. Okay, it got deleted, so I won't be able to execute it at all. So the same thing will happen if I choose Rubius. Extract all. Let's extract here. So it is not prompting me for the password because I already unzipped the file before with the password, so I think it saves the password somewhere on the cache. That's why I'm not asked for the password again. But these two zips are password protected. You can put any password that you want. It won't make a difference. So as you can see, even Rubius got deleted. So now, just for a proof of concept, what I will do is I will turn off Microsoft Defender. Okay, what did I do here? Okay. Click here. It will ask me for an admin password, which is normal. Okay. And now let's redo the same. Let's redo the same. So sorry, it just telling me, please turn on Windows Defender again. So let's delete this. And this time let's test with to extract again. Okay. So this time it got extracted. Let's do the same with Rubius. Extract. Okay, here's it. Boom. Both of them are extracted. Let's try to execute them. Let's execute simple exec from PowerShell. Not the zip one, but the one here. As you can see, I just got a calculator. As I said, it is just a calculator app. It is considered malicious because of the way calculator is launched. We will discuss more about that later. And the same thing with Rubius. Now Rubius will run normally because I turned on Windows Defender. As you can see, it runs with the help of with the help message that is from Rubius with the Rubius version. Okay. So now let's just turn back on Windows Defender. Okay, I'm not sure what I clicked. Okay. Okay, I need password too. And now they should be detected again and deleted, these two, after some time. So that was it for the demonstration. So now that we saw that Windows Defender can actually defend, what we will do is that we will refine our goal. So what we will do in this course, what is the purpose? So what we'll do is that we will create a Go program that will drop the detected exe and run them in a way that will make Defender happy. So we will more focus on the MSF Venom part for the case of simplicity, as you will see later. What we will do is that we will run the calculator the payload of the calculator.exe in a way that it will make Defender happy. So that was it for this course. Thank you and enjoy. Hello again everyone and welcome to Malware Development with Go, lecture 5. So in this lecture you will be creating your first helloworld.exe. So let's get started. So what we'll do is that we'll go to our development VM where we have Go installed. In my case it's Kali Linux. I created a new folder called Hello World and we will be making our Hello World project in there. So whenever you start a new project in Go, you want to initialize the Go module. So to do that, you do go mod init and you put your package name. For my case, the package name will be hello world. What will that do is that it will create a new go.mod file, as you can see here, and the go.mod file will contain information, mainly the module name and the Go version. This module file will be updated when we will code, and it will be automatically updated. So after that, you just open your favorite Go IDE. So for me, it is NeoVim. And there we will start making our code. So I normally prefer to put all my main.go under a CMD directory. So what I will do is that I will create a CMD directory and I will create a main.go file in it, like you can see here. So now I have a CMD and the go.mod. As you can see, I have my LSP, my language server protocol, that's already telling me there is a syntax error. So if you are using VS Code or any JetBrains IDE, it will be automatically installed. You will also get this error when you start, what we'll do, because in Go files, it is expected to have a package name at first. I don't have a package name, hence the error, but this can be easily fixable by adding just the package name. In our case, the package name will be main. Every main package normally needs a main function, so let's create that. And in my Go function, I will start writing my code. So in Go, there's a lot of way to print. You can just use print, but I prefer to use the fmt package for a lot of reasons. So I will use that. So as you can see, there's a lot of possible way to print. You can use printf, println, or print, just print. I will use the fmt.println. And here I will write my message. For example, hello world. What you will notice is that my LSP automatically imported the fmt package for me because I wrote an fmt. Again, if you use VS Code or any other IDE, it will do that also for you. Otherwise, if I change your IDE, if it does not do it for you. And this is basically a hello world in Go. Now that we wrote the code, what we'll need is to compile. Some IDEs have like a compile button or stuff like that. In my case, I like to do it in a shell. I advise you to do it in a shell because for me, it is the only way you will understand what is actually happening. Instead of just clicking button, it is very interesting to see how Go was designed to be used in a command line. So first, what you will need to do is to specify what target you will want to compile. For example, if you want to compile to Windows, you just put the GoOS equal Windows at first. It will initialize an environment variable in Linux called GoOS. You say that the Go arc will be AMD 64, meaning it is not ARM, for instance. And you will just call the Go binary. You will do Go build, and you will put the path to your main.go. So this will normally generate a .exe file, as you can see here. So the size of the file is a little big. You see it is 2 megabytes for just a hello world. What is actually happening is that Go is embedding all the runtime and all the library needed for the main.exe to run, which explain why it is 2 megabytes. If you code in C++, you will see it will be like, I think, 1 kilobyte maximum. But if you don't statically link the binary in C++, you will need to have a lot of libraries on the target system. This main.exe, you can put it on any Windows on AMD 64 and it will run. You don't need to have any C runtime, and you don't need to have any DLL. In any specific DLL, of course, besides the default one like ntdll and kernel32.dll, as we saw before, that are necessary to talk with the kernel. So, but even with that, the size is a little bit too big. There are some tricks to make it smaller, and is to use some additional flags. For example, the trim path that will trim some symbols from your binary, and this magic flag, which will turn on some optimization. I will let you check the doc if you want more detail about this. But basically, if you use these two flags, the binary will be much smaller, as you see now. Compile. And the binary is now about 1 megabyte to 1.5 megabyte. To check if this will run well, let's just copy it to our virtual machine. So there's a lot of way to copy, to share files between virtual machines. I use a shared folder, but you can use again whatever you want. For instance, you can zip files, send them through email, or run an HTTP server on the Kali machine and download the file from Windows. There's endless possibilities. The important thing is just to transfer the file to the machine, and then in a PowerShell, you can run the file normally, and you see I will have hello world. So that was it for this video. I hope you really enjoyed your first experience with Go and how to and you noticed how easy it is to compile from Linux to Windows. It just by just changing environment variables. So thank you, and please enjoy the rest of the course. Hello again, everyone, and welcome to Malware Development with Go Lecture 6. So in this lecture, I'll be introducing the Windows API. So let's get started. So first, let's start with a high-level view of the Windows API. Imagine you are a developer who wants to make an application on Windows. To do that, at some point, you will need to interact with the Windows operating system. To do that, Microsoft will provide you with a set of functions called the Windows API that you can call in your code. This is why, as you can see here, the Windows API are defined in user mode. Normally, a lot of times when you call your Windows API, the call will go to the kernel. So some code will be executed in kernel mode, and then, if needed, the kernel will interact with the hardware, for example, to allocate memory for your application to work. But at the end of the day, what you will do is just call the Windows functions defined in the Windows API and provided and very well documented by Microsoft. So how does the Windows API work? It works with a new format made by Microsoft called Dynamic Link Libraries, or DLL. You may have encountered, if you are using a Windows operating system, that some files have the .dll extension. These files are actually libraries that cannot run as a standalone. They need to be imported by another process, and then the function defined in them can be called. So let's take an example together. For example, you want to use the message box A function. If you call this function, what will happen is, as you can see here at the end, a small message box will open with a message that you write. For example, here it is hello world, which is given as an argument for this function. So if you want to use message box A, the first thing you will want to do is to see which DLL exports message box A for you to use. And to do that, you just check the Microsoft official Windows or official documentation. For example, I am checking message box A function definition. At some point, you will see that in this article, there is the requirement. You click on it. You will see that in the requirement, the DLL is user32.dll. What then your process will do is will load this DLL file into his own process memory, and at code level, you will then be able to call message box A with a specified argument given by Microsoft. And after calling the message box A correctly, you will have a message box opened. Some notes. Sometimes you will have to specify in your code that you need to import this DLL. However, there are some DLLs that are imported by each process at the start. For example, anti-DLL.dll is imported by each process without for you needing to import it by hand. If you want to check about a specific Windows API, you need to you need to go check the Microsoft documentation, which is the place to go check for a regular Windows API. Very important point if you want to get more advanced later into malware development. What is happening behind the scene when you call a Windows API is something called DLL chaining. For example, imagine you have a file.exe that inside it, when you compiled it, there's a call to create file W, which is a Windows API that lets you create a file on Microsoft Windows. If you check Microsoft Windows official documentation, I think you will see kernel32.dll. So you import kernel32.dll, which I think is already imported by a lot of processes by default. You call the create file. Behind the scene, the create file function in kernel32.dll calls another create file defined in kernel-base.dll, which then in turn call a function called anti-createFiles in anti-dll.dll before going to kernel land and doing what needs to be done in the kernel. So that was it for this lecture. I hope you have a better view now of what the Windows API is and what are DLLs. In the next section, we will see how to call the Windows API in Go with a lot of methods. So thank you and please enjoy the rest of the course. Hello again everyone and welcome to Malware Development with Go Lecture 7. So in this lecture, we will be talking about a first method to call the Windows API in Go. So let's get started. So first, the first method that we would like to use to call the Windows API in Go is to use the official Golang Windows package, which is provided by the GoTev team. The full documentation can be seen in this link. So when you go to this link, you will see documentation about each Windows API function being converted to Go. For example, if you remember the message box A from the last lecture, it has the equivalent in the Golang word, which is the function message box, and you can see the function definition here. So let's see a practical example how we can call the message box and create a message box exe that can open a pop-up for the user. So to do that, we will go to our development VM and we modify the previously created Hello World project. What we'll do is that we will, instead of printing the Hello World with the FMT package, we will use the Windows package that can be imported by importing golang.org/x/sys/windows. So when you click on it, if you have automatic completion in your IDE, you will see that something has been imported here. But however, your linter will say that it is not happy because it could not import Golang Windows. What you do in these cases is just go back to your terminal and run go mod tidy, and it will download the Golang package from golang.org. So when we go back to our IDE, you'll see that now the error is different. It said that the Golang package is imported but is not being used. So let's just use it. We will call the message box, which take many arguments. Most of these arguments are imported for this function. The one that is not used is this one. So let's just put some dummy. Let's just put 0 here. And now we will need to modify the text and the caption and the box type. So for the box type, we will use the standard OK box. Up. So in the Windows package, we have windows.mbok to simulate an OK box. And now we still have to deal with these two parameters, which are the text and the caption. So first, let's create a variable called the text string, and we will say that it is hello world. And another variable that's called caption string, that it's called pay, for example. So sadly, we cannot pass text string and caption string to these parameters in the function because, as you can guess from the naming of the variables, these are strings, while this function accepts a pointer to a unsigned integer 16. However, in Go, there is a few solutions for that. In the Windows package, there is a function to convert string to unsigned 16. So you will get an array, And I think there's a way to get, you can use that and you will get a pointer directly. So you just you just call this function here with text string, and you do the same for the caption. And if you do that, it should not give any error. However, we still have one error here because Go does not accept that you import a package and you don't use it. We can just use it, or we can just delete the import, but let's just use it in our case. For example, message box opened. Let's say cold, because we are not sure that something has opened. Just say that we are sure that if you are here, there's a message box have been called, at least. Let's check if it returns some error. Yeah, so what happened is that this function return an integer and an error. For our case, let's just check if the error is different from the nil value. Yeah. So the first variable, we won't use it. We just use the second, which is error. And we check that if error is not nil, then something bad happened, and we will just print something to know. Okay, something bad happened. You can even print the error if you want. Okay, so let's do a quick recap. We import the Golang Windows package. We create two string variables, which are hello world and hey. We call the message box. The first parameter we don't care about. The second parameter, we convert the string to an unsigned pointer. The third parameter, we convert the caption to an unsigned pointer. And the last parameter is just the type of the box that we want. Then the message box will return an error. We check if the error is not nil. It is not nil. We say that something bad has happened, and then we print that the message box has been called. So now that we have this, let's just compile. Okay, it's normal. I put the wrong path. And now that it has compiled, okay, I should not have used the A. So the A will just not use the cache and will just redo everything from the start. This is why it takes sometimes. But yeah, it compiled. So we have the main.exe. We transfer it to our VM. Let's call it message box. And if we go to our VM, we can call message box. And let's hope it works. Yeah, so we have a hey and a hello world. When we click OK, we say we have the message that the message box has been called. So this was it for this first experience with Go and the Windows API. In the next lecture, we will see other ways that we can use to call message box without using the predefined version in the Golang package. So thank you and please enjoy. Hello again everyone and welcome to Malware Development with Go lecture 8. So in this lecture, we'll be seeing another method to call the Windows API in Go. So let's get started. So in this method, we'll still be using the Golang Windows package, but this time, instead of using the predefined version of the Windows API, we will load the DLL into memory using Go, and then we will run the Windows API from there. So this is actually pretty interesting because imagine you want to call a Windows API, you cannot find the Windows API defined in the Windows Golang package. In that case, you will use this method to call it. So let's do a quick demo. We'll still be creating a message box, but this time we will load the DLL and then call the Windows API. So this was the code we previously wrote. So let's just modify it a little bit. I will comment this line because it will be useful to notice the differences between the two methods. What I will do is I will start by loading the DLL into memory. And to do that, I will define a new variable. So we saw earlier that the message box A and message box W are in user32.dll. So I will load the Windows 32.dll, and to do that, it's actually pretty easy to do that in Go. You use the new lazy DLL, and you put the DLL name. So now we have loaded the DLL into memory. We will find the address of the Windows API we want to call in it, and to do that, I will define also a new variable called and I will use the previously created variable with the new proc function with the name of the Windows API. In this case, I will be calling message box wide. Okay. So now that we have this new variable, we will just have to call the function using the call method. So as you can see from the documentation, the call method only expect type called uinptr. So all of this argument that you see here, 0, and the pinned uint16 pointer, these two, and the windows.mbok should be converted to unsigned pointer as required by the call function. So we start with 0. So actually it is really easy to do that with 0. We just do unsigned ptr 0. Okay. For the last one, it is also easy. So beware of the order because it is important to actually follow these orders. So for this one, it is easy. So and now it comes to these two here. Okay. So I will start by saving these two conversion into new variables. Okay. So I will call it text tf16. And for the other one, okay. Caption UTF-16. Caption string. So you may think, okay, so here we have an UN16 pointer. You may think that, okay, I can convert it directly to unsigned pointer. We can try further. But as you can see, we will get an error when we do that by the linter. I click, okay. So, okay. One mistake. Fixed, okay. So as you can see, my linter is not happy. It is saying that, okay, I cannot convert the text UTF-16 of this type to type unsigned pointer. So this is basically due to the fact that Windows is a safe language. It is trying to avoid unsafe conversion as much as possible to avoid memory errors. However, there's a workaround for this. We will convert the pointer to inside integer 16 to unsafe.pointer, which is another a specific type in Go. Then we will convert the unsafe.pointer to unsigned pointer. So to do that, we'll use a package called the unsafe, and we'll convert this to pointer. So as you can see, this what has been highlighted is of type unsafe.pointer, which can then be converted to whatever you want. In our case, it will be a convert to unsigned pointer. We'll do the same for caption string. Unsafe pointer. What did that? Okay. No, it should be a caption UTF-16. I think to be more clear, these are not a UTF-16, it's a UTF-16 pointer. So I will add PTR at the end of the variable name because it's better. Did I did? Okay. And we should be good. So a quick recap what we are doing. We are importing the FMT package, the unsafe package, and the Windows package at first. We are defining two strings. We are converting these strings to UN16 pointers, to pointers to UN16, using the string to UTF-16 pointer. We are then loading the user32 DLL into memory, are finding the address of message box W, and then we are calling the Windows API by converting everything to unsigned integer pointer. And then we are printing message box code. So now that we have this, we should be good. Let's compile. Okay. So we have our new main.exe. We shall copy that to our Windows VM. So I will call it messagebox2.exe. Then if we go to our Windows, I just call messagebox2. And as you can see, it is working as the first one and printing message the message box has been called. So this was it for the second method to call the Windows API in Go. I hope it is clear. As you will see later in this course, there will be one use case where we will have to load the DLL by hand because some functions are not defined in the Windows official package. So thank you and enjoy. Hello again everyone and welcome to Malware Development with Go lecture 9. So in this lecture we'll be seeing a third method to call the Windows API in Go. Let's get started. So in this method we'll be using the Golang syscall package instead of the Windows package. What we'll be doing is the same as we did before. We will load the DLL into memory with Go, then we will run the Windows API from there. So behind the scene, the Windows package relies on the syscall package, and the usage is actually very similar from a DLL loading perspective. So as a demo, we will still be creating a message box executable, and the change is actually pretty simple. You take the code that we did before, and you replace on this line the windows.newLazyDLL by syscall.newLazyDLL. And you will need to import the syscall package. And after doing that, your code will compile and execute the same message box as it did before. So that was it. I wanted just to highlight the fact that behind the scene, everything is going through a package called syscall, even the Windows package. So thank you and please enjoy the rest of the course. Hello again everyone and welcome to Malware Development with Go lecture 10. So in this lecture we'll be talking about shellcodes. So first let's talk about what people think a shellcode is. So you may see a lot of people writing on the internet that shellcode is just malicious code. So this is basically due to the fact that in the past, shellcode were used to exploit a vulnerability called buffer overflow. This is why a lot of people think that shellcode is just the same as some malicious code, which is not the case. Because in our context, what you need to know is that shellcodes are a set of bytes, and these bytes are just like assembly opcodes that can run from any place in memory. So shellcodes are just a set of bytes that run from any place in memory, which is why sometimes we can call them peek or position independent code. So the real definition and the real technical detail of shellcodes is complex, and creating shellcodes is even more complex and out of scope for this course. So, however, we need shellcodes. So we will just use tools that create shellcodes for us. So there is a bunch of tools that does that on the internet. I'll be using a tool called MSF Venom for simplicity, because it is simple to use. Plus, it is by default with Kali Linux if you opted for the Kali Linux as a development VM. So I'll be using MSF Venom in the rest of the course to generate my shellcodes. So let's do a quick demo so we can get a more practical idea of what is a shellcode is. So let's go to our development VM. So to generate a shellcode, I will use MSF Venom in this way, this command. So basically, I am calling the MSF Venom binary, which is by default on Kali. I'm using the -p parameter. So -p stands for payload, and I'll be using a Windows payload for x64 architecture, and I'll be using the exec payload, which will just execute a command I can put as an argument. So the command is calc.exe. I specify it this way, and then I'm using the -f option to specify the format I want my shellcodes in. So for this case, it is eggs for hexadecimal. So when I run this, what I will get after some time is a set of bytes. As I said, shellcode is a set of bytes, which is 276 bytes in our case, and here is the shellcode that can run from anywhere into memory with a hexadecimal representation. What is interesting is that we can specify a lot of formats we want our shellcode in. For example, let's say I want my shellcode in the Go format, and what this will give us is something pretty handy, which is an array of bytes, which are actually just the hexadecimals that are here. As you can see, FC 48, 83, but it is very practical because you can just copy this and put it in a variable in your Go code. What is even more interesting is that you can say that you want it as the exe format and redirect the output to a file. For example, this was how I created the simple exec.exe as the first when we tested against Defender. So you do that, and you will get an executable that will run the shellcode. You can see it here. Another interesting thing that we will use through this course is that we will use the raw format, which actually will just print the shellcode in a raw format for us. So it will be in binary. This is why it is not readable. What we will do, we will redirect all this binary data to a file called clear_shellcode.bin. Why I'm saying clear? Because it's just the clear text what has been outputted from MSF Venom. So if you don't have MSF Venom and you still want to follow the course's steps, what I will do is I will put the clear shellcode.bin, which has been generated using this command, into the course's attachment. So yeah. So that was it for this course. I hope shellcodes are more clear for you and you can now generate shellcodes using MSF Venom. So thank you and enjoy. Hello again everyone and welcome to Malware Development with Go lecture 11. So in this lecture we'll be introducing loaders. So first let's start with the definition. What is the shellcode loader? Sometimes called also a dropper. The loader is the code that will take the shellcode, it will put it into memory and it will run it. And as we said earlier, that shellcode can run from anywhere from in memory. The shellcode should run normally. Very important point is that loaders are not specific to Windows. You can see loaders for Linux, loaders for Mac, but in our case it will be for Windows. So what we'll do now, so now the next steps are create an executable called loader.exe. The loader.exe, it will take the previous lecture shellcode, meaning the clear shellcode.bin, and it will load it into memory and run it. And to actually do that, the loader.exe will just call multiple specific Windows API in a specific order, allowing it to load the shellcode into memory at first and then run it. And hopefully at the end, the loader will not be detected by Windows Defender. So now that we refined our goal, let's see what exact steps are needed to bypass Windows Defender. Hello again everyone and welcome to Malware Development with Go lecture 12. So now that we know what the Windows API is, we know how to call the Windows API in Go, we know what a shellcode is, we know what a loader is, we can now attack the steps to bypass Windows Defender. So let's get started. So the big steps to bypass Windows Defender are actually the big steps to create our loader.exe. These steps are shown here. So what we will start by doing is to prepare the shellcode. So you remember the clear shellcode.bin that we created in the shellcode lecture. We cannot put it as it is into loader.exe because the shellcode, if you upload it to VirusTotal, you will see that it is detected by a lot of antiviruses and EDRs. So we don't want that. What we'll do is that we will prepare the shellcode beforehand. We will encrypt it. You will see we will use XOR encryption. Then we will use it in our loader. After preparing the shellcode, the loader will allocate memory into the process space, and it will do that using a well-documented and well-known Windows API called VirtualAlloc. After allocating memory and space in the process memory, we will copy the decrypted shellcode into memory using some Go copy functions, and we will make sure that this region of memory is executable. And to do that, we will use a Windows API called Virtual Protect. So now that we have the shellcode in memory and executable, we can run the thread using a Windows API called CreateThread. So these are the big steps of the loader that we will create. So now that we know the steps we want to follow, let's start by preparing the shellcode. Hello again everyone and welcome to Malware Development with Go lecture 13. So in this lecture, we'll be making the program that will do the XOR encryption for us. So let's get started. First, I will go to my development VM. So I am already in a folder called prepare, which will be the name of our program. And in this prepare folder, I have put the clear shellcode.bin that we generated earlier in MSF Venom and that you have somewhere in an attachment in a lecture. So I will start by initializing the Go module. And let's get started. I will start by creating, as I did before, cmd/main.go. And in it, I will put my main package, main. And I will be starting the main function directly. I will start by defining a key, which will be the secret key. for our XOR encryption. It will be a single byte. Should be a random number. For instance, here 133. Okay. I will then ask the user for the path of the shellcode, which can be anywhere on the machine, and I will do that using the flag package, which will take a command line argument. So, and to do that, you will import the flag package and use the .string function. So here you specify the argument name, the default value. I won't put anything, and there you'll put like a help message for the user, path of the shellcode. Okay. I will put this in a variable called pointer to shellcode path, because the string return a pointer actually. We can check the help function together. The string return a pointer to a string that will contain the argument specified by the user. And to get the actual parameter, you will need to do the flag.parse. And to get the shellcode path, we will just dereferentiate the pointer using the star. So to better understand what this will do, these 3 lines. So at the end, we will have a binary. And this binary, it will be called, for example, prepare. And when someone runs prepare, he needs to put the file argument with the shellcode path. For example, it can be home, Kali, clear shellcode.bin. So at the end of these 3 lines, the shellcode variable, let's call it shellcode path actually to be better consistent. So the shellcode path variable will contain this string. So now that we have the shellcode path, we need to open it and read the bytes in it. And to do that in Go, it's actually pretty easy. You use the os.read file and you put the file you want to read, the path. We have already that in the shellcode path. And what this will do is you will give it the file name, and it will give you a byte array of the bytes inside the file. We will call that clear shellcode byte. And it returns 2 things. It returns that and a potential error. Maybe the file is not found. And let's check this. We do if error is not nil. Let's print something. For example, you can print kfmt dot int ln error winning file, and we can print the actual error. Okay. So now we have the bytes of our shellcode in a variable called clear shellcode byte. And now we will go through each byte of the shellcode, and we will put it in another variable called encrypted shellcode byte after XORing it with the key. So let's do that. First, let's define a variable called encrypted shellcode, for example. Okay, which will be a byte array, an array of bytes. Okay. We will go through each byte of the clear shellcode byte. And we will append to encrypted shellcode. We will append clear shellcode byte at the byte at the I position of the clear shellcode byte XORed with the key. So in Go, as many languages, I think the XOR is this symbol. So we are taking the byte of the shellcode and XORing it with the key, storing that in the encrypted shellcode. So now that we have XORed all the shellcode, what we'll do is that we will print the encrypted shellcode in a friendly format for us to copy and paste later in our loader. So there's many ways to deal with this at that point. For example, you can save the result in a file. I will just print it, and I will do that using a second for loop. And I will print without using the formatting. I think in Go there's the formatting with FMT. I will just print it normally by hand. I'll start by printing the byte like this. So basically the difference between print and println is that print won't return to the line, but println will return to the line. As you notice here, I put println. Here I won't put println because I want the byte to be next to this string. Then we will go in another for loop. I will just copy this one. What we will do is that we will check if we are at the end. So if I equal ln shellcode. So I'm using clear shellcode byte because the encrypted shellcode and the clear shellcode have the same size. So it won't be an issue. And what I will do is that I will just print ln because we are at the end. The clear shellcode byte I, and we'll be closing the brackets. If you are not at the end, I will just print without a print return to the line. Print clear shellcode byte. No, okay. Small mistake. We don't want to reprint the clear shellcode byte. We want to print the encrypted one. Yeah. Encrypted shellcode. I with a comma and a space. Okay. So I bet there is some more clean way to do it, but it should work. So let's just do a quick review. We are importing the flag and the FMT and the OS packages. We are defining a key, which is a byte. We are taking the file parameter as a string from the user. We are reading the byte from the path provided by the user, printing an eventual error in case the file is not existing or we cannot open it for some reason. We are defining a variable called encrypted shellcode, which is a list of bytes. We are going through each byte of the clear shellcode, and we are XORing it with the key and putting the result into encrypted shellcode. Then we are printing the result for us to copy later. So this seems correct. What we need to do at this point is just go build CMD. Go. Yeah. Okay. This goes here maybe. Okay. So we have our binary called prepare. And if you are lucky enough, if I put prepare, -h first we see that, okay, it is expecting a file pass. The -h is for the help. And if I put the file pass, if you're lucky, we'll get this to work the first time. Yes. So we will have the encrypted shellcode that we will copy paste later in our loader. So that was it for this lecture. So thank you and please enjoy the rest. Hello again everyone and welcome to Malware Development with Go lecture 14. In this lecture we will be starting the loader in Go and it will start with the XOR decryption. So first let's go to our development VM. So on this tab I have the MSF Venom clear shellcode.bin that has been prepared using our previously created prepare binary. On this tab I am on the loader folder. So we have nothing in it. What I will do is I will initialize the Go project. This created the go.mod file, and let's get started. I'll start by creating the cmd main.co like always. Package main, function main. What we'll do is that we will redefine the key. Let's call it secret key this time, which will be the same as before. The byte representation of a random integer, but the integer should be the same as the one used in the prepare. So it was 133 in the prepare. In the loader, it should also be 133. What I will do is that I will copy this shellcode that has been outputted by the prepare and copy and paste it in my loader. And I will put that in a variable. I will call this the variable encrypted shellcode. And to get the clear shellcode, let's call that, okay, let's create a variable clear shellcode, which is of type byte. What we'll do is that we will again take each byte from the encrypted shellcode and XOR it with the key. This basically works because the XOR encryption and the XOR decryption function is the same. So we will just loop do a for loop over each byte of the encrypted shellcode. And we will append the encrypted shellcode with the secret key. And when we do that, so basically secret key, because it is the same as the one before, if you XOR the same thing with itself, it will cancel out. You will end up with the clear text shellcode. So now after this loop, here we will have the clear text shellcode as outputted by MSF Venom without the XOR. This whole manipulation, encrypting and decrypting the shellcode in the loader, will help make our loader at the end not detectable by Windows Defender, because we are avoiding the fact that the clear text shellcode is in clear text in our loader, which is not the case here because we have the encrypted shellcode. So that was it for this start of the loader code. We started by decrypting the shellcode, and then we will continue by allocating memory. So thank you and please enjoy the rest. Hello again everyone and welcome to Malware Development with Go lecture 15. So in this lecture we'll be starting by allocating memory in our process space using VirtualAlloc. So before starting doing the code, let's present quickly VirtualAlloc. So VirtualAlloc is used to allocate memory in our own process memory space. Here is the definition from Microsoft official documentation. It takes 4 arguments. The first one we don't care about. The second one we care about. It is the size of the allocated memory that we want. So basically this should be the size of our shellcode. The allocation type, which will be a fixed value, and the FL protect type, which is an important parameter for us because we can, for example, we can specify the protection that this memory, this newly allocated memory will have. For example, it can be read-only, so this memory can only be read by the threads. It can be read-write. It can be read-write execute. So for our case at this point, it will just be read-write. We won't create read-write execute because opening read-write execute with VirtualAlloc is something that is detected a lot. So we will first open read-write, then we'll see later how to change the protection. But for now, this will be the read-write value. So this is the C++ documentation from Microsoft official documentation. When we do that in Go, what we will do is that we will use the Windows package to call VirtualAlloc because VirtualAlloc is already predefined in Go. So let's go to our development VM and start coding. So here is our loader from before. So let's start by allocating memory. We can add a small message. Println. So I think there's a logger package to do that more clean and Go, but I'll just print memory. Then done. Yeah. And here between the two, I will use the Windows package dot VirtualAlloc. It's weird, I don't get the autocomplete. Okay. Small fix. Yeah, so I need to do that like we did before, but tidy. So it downloads the package. Okay. And now I will have the auto completion. Yep. So okay. So here we don't care about this. So let's put it to 0. The size, which will be the length of our clear shellcode, as we will copy the shellcode in it at the end. The alloc type. So for this, we need to have this to memcommit or mem reserve because so this basically is a complex concept using memory pagination and with RAM. So I won't get into details, but these are actually just numbers. You can check the Microsoft official documentation, but as you've seen, there's just X numbers, and we need to have this here. Otherwise, it will be don't work. So let's just put that here to reserve and commit memory with the RAM for our shellcode to run properly later. Now the most important parameter is this one, which is the type of protection we want to have it. We can put read. Yeah. We can put page read only. So it's page You can put page execute, page read write, page no access, so no one will access it. We'll just put read write at this point. And of course, we have a problem because ln shellcode is an integer and it is expecting a unsigned pointer. We just do this. And we should be good. So VirtualAlloc, what will it will return a pointer to the start of the newly allocated memory and an error. So we will save that to the variable p newly allocated memory and the error. And we will, of course, as always, check if the error is not nil. If it is nil, we will print n failed to allocate memory, and we print the error. Okay. And of course, we have some linter issues because this has not been used yet. We will use it later. So that was it for the memory allocation. In the next lecture, we will see how to copy the shellcode to the newly allocated memory. So thank you and please enjoy the rest. Hello again everyone and welcome to Malware Development with Go lecture 16. So before continuing our loader implementation, I would like to talk quickly about some other methods that can also be used to allocate memory in processes. So let's get started. So previously what we did is that we used the Windows API call called VirtualAlloc to allocate memory in our process. However, there is another method to allocate memory, which is VirtualAlloc X. You can see the Microsoft documentation here. It will allow you to allocate memory not in your process, but in a remote process. I really invite you to check this out if you want to do a loader that inject not in your process, but in a hijacked process. There is also a completely other method to allocate memory in your own process space, and it is to use these two API calls to create file mapping and the map view of file. Don't be tricked by the name file here. You don't actually need to have a file anywhere on your victim machine. So by combining these two, you can actually allocate memory in process space. I really invite you also to check this documentation and how to use them in case you want to modify the loader to allocate memory with these two Windows API instead of VirtualAlloc. So thank you for listening. So that was it for some other methods to do memory allocation. However, for our loader, we stick with VirtualAlloc. So thank you and enjoy. Hello again, everyone, and welcome to Malware Development with Go, lecture 17. So in this lecture, we'll be copying the shellcode, the clear text one, to our newly allocated memory address. So let's get started. Let's go to our development EM and start the copying shellcode step. I will write a comment here. Code. Let's even write a message. What did I write? I copied the wrong. Okay. Copying shellcode. And I will write done. And here we should copy our shellcode. So in Go, we have a function called copy that we will use. So as you can see, the copy function expects a source and a destination. And the source should be an array of type anything, and destination should be an array of type anything. Of course, for us, type will be byte, and the source should be the clear shellcode on which we copied our encrypted shellcode XORed with the secret key. So this should be easy for the source. However, for the destination, it will be a little bit tricky. So first, let's set the source and keep the destination for later. So here, let's put clear shellcode. Okay. Okay. And for the destination, I will create a new variable called destination. And to define the destination, what we'll basically do is that we will transform our newly allocated M, which is of type unsigned pointer, to an array of bytes. Basically, and how we will do that, we will use the unsafe package, destination equal unsafe dot slice. So let's check slice documentation. So the function slice returns a slice whose underlying array starts at pointer and whose length and capacity are len. So they explain it a bit. What we will do is, so the length will be the length of our clear shellcode, because we want to transform it to the same size of our source, which is clear shellcode. And so to have a list of bytes, what we will put as arbitrary byte is as arbitrary type is we will put the type byte. So that way, here we have a pointer of a byte. At the end, we will have an array of bytes. So let's first set the length. So this will be the length of our shellcode. I don't know why my autocomplete is messing up a little bit. Length of our clear shellcode. Okay. And here we still have to transform P newly allocated mem to a pointer 2 bytes. Do that, you may think that, okay, let's just do like we do in C or C++. Let's just do this. However, it won't work. Let's just fix it. Yeah, 2 points because it's a new variable. However, it won't work because, as I said before, normally Go is safe, so we cannot cast pointers like we do in C and C++. What we will need, though, is to use the same trick as we did before, is to transform P newly allocated mem into an unsafe pointer. Then we cast it to a byte pointer. And because here we have a byte pointer and we specified the ln, at the end, the destination will be an array of bytes. And because clear shellcode and destination are an array of are both array of bytes of the same size, everything in a clear shellcode will be copied at the memory location of P newly allocated mem, starting at P allocated mem and ending at ln shellcode. So to do that, we just unsafe pointer we should get a small warning because we are doing some unsafe stuff, but it should work. So that was it for copying the shellcode into your own memory. So after the step, whatever bytes are in clear shellcode should be in the memory of our process. So thank you and please enjoy the rest of the course. Hello again everyone and welcome to Malware Development with Go lecture 18. So in this lecture, we'll be talking about making the memory executable. So basically, if you remember, when we allocate the memory using VirtualAlloc, we specified that the memory is page read-write, meaning we can write in it and we can read from it. This is why we were actually able to copy the shellcode in the memory. However, as you will see later in the next lectures, we want to execute the shellcode at some point and to run threads. So to do that, we will need to make the memory executable. So to change the memory protection, we will use another Windows API call called VirtualProtect. Here is the documentation in C++, and we are lucky because VirtualProtect is also available in the official Windows package. So it takes 4 arguments. Basically, the start address of the memory in concern, the size that we want to change the protect for, how many bytes we want to make executable, the new protection, so it will be read execute, and the old protection. So basically, this is an out parameter. You can see here are in parameters, meaning that we should specify them, and here it's an output parameter. So basically, what VirtualProtect does is that it saves the old protection it had in a pointer that we need to put. And the same thing are in Go. There you have the address, the size, the new protection, and the old protection saved in a pointer. So let's do this, and we'll go to our loader. We'll start by printing some logging stuff, changing protection, and done. Okay. And what we'll do is that we will just run Windows dot virtual protect. Okay. So it takes the address, which is basically this one here, newly allocated mem. The size, which is the length of our clear shellcode. And of course, we need to modify that to unsigned pointer for the function to be happy. The new protection, which will be Windows.execute read. Oh, I think it's page execute read. Yeah, sorry. So you may say, okay, so we have execute read. Why not open execute read write from the start in the VirtualAlloc here? So it is not recommended to open execute read write because this is malware behavior to open execute read write. Normal process normally don't do that. This is why we are doing this in 2 steps. First, we are opening read write, then we are changing the memory protection to execute read. And then we will need to save to give a pointer to a variable to save the old protection. And we will create a variable called old protect that is of type int 30, and we should be good. Of course, we can check the error. Copy that. Basically, we can do that because VirtualProtect returns an error, as you can see here. And we'll write a message in case there's error, failed to change protection. So yeah, this is it. This looks good. So this was it for this changing of protection. Thank you, and please enjoy the rest. Hello again, everyone, and welcome to Malware Development with Go lecture 19. So in this lecture, we'll be talking about creating a thread in the current process. So let's start. So to create a thread, we will use the Windows API call called CreateThread. So basically, as you can see, this is the documentation from the Microsoft official documentation. It takes a lot of argument. Most of them will be 0, except this one, which is the address of the start of our shellcode. So when we do CreateThread with this being set to the start of our shellcode, address in memory, it will run our shellcode. So this is the documentation into C++. If you want this to find the documentation in Go, I personally did not find the CreateThread into Go documentation, but this should not be an issue because as we saw before, CreateThread is in a DLL, which is kernel32.dll. We can just load kernel32.dll and run CreateThread. So let's get started. What we'll do is that we will start by writing some logging stuff with fmt. I don't know what I did. Okay. Write a comment. Launching thread. Okay. Launching thread. Put done. Okay. We will create a variable called kernel32.dll equal to windows.lazy.dll and the name of our DLL, which is kernel32.dll. Cannot convert kernel. Yeah, it's new lazy, not lazy. Okay. And so I'm just following the same steps in the calling Windows API in Go method 2. So, and then I will create a variable called CreateThread. Let's call it proc CreateThread to be more consistent. Like this. Equal kernel32.dll dot new proc. And here I will just put the name of the Windows API call, which is CreateThread. Then I will just need to call the CreateThread with CreateThread.call. So as I said, first parameter is 0, the second is 0, the third one is the shellcode address, which is p new allocated mem that we got from VirtualAlloc, and that now after copying contains the clear shellcode with execute read permission. So we need to have this read to be which we done before, and then we will put the new allocated pointer 0 0 0. So actually, yeah, we don't care about anything else than except the start of our shellcode. And this will actually return a handle to the new thread and an error. We can check the error like we always do, because why not? Failed to run thread. Let's put that. Okay. Okay, we may think that okay, we are done, but sadly no. We still have one last step, which is to wait for our thread to finish, because when this has been run, our thread maybe has not finished yet. So the main thread may be killed before the create thread is done. So we'll just need to wait for it. And actually this is pretty easy. We just choose the Windows.wait for single object. Here we put the handle that we got before. And the time, so we'll just wait for infinity for it to finish. And yeah, it's not happy for some reason. We will make it happy. Okay, what did I do? Okay. So basically, it expects a Windows.handle, but here we got an unsigned pointer. We just convert the unsigned pointer to Windows handle. This should be easy. Because basically behind the scene, a handle is just an unsigned pointer. That's why the conversion worked directly without needing to do some tricks. So this is it. Our shellcode should be ready. our shellcode loader should be ready, and now we just need to test it. So thank you, and please enjoy the rest of the course. Hello again, everyone, and welcome to Malware Development with Go lecture 20. So before testing our loader that we implemented before, I would like to give some quick notes on other ways of launching the threads. So let's get started. So before we use the create thread because we want to create a new thread in our process. However, there is a function called create remote thread, which gets some more arguments. And here is the definition in C++. And this will let you create a thread not in your process, but in a remote process. So this can be really handy if you want to implement a remote shellcode injection, which we did not do here. We just do a self shellcode injection because we are injecting in our own process. There is also a completely new method to launch thread, which is a queue user APC. APC stands for asynchronous procedure call. Here is the function definition. With this, you can also launch threads. I will let you check the documentation for more detail. What is the queue user APC and what are APCs in more detail. But it is really interesting to know that create thread is not the only to run code. So thank you, and please enjoy. Hello again, everyone, and welcome to Malware Development with Go lecture 21. So in this lecture, we'll be testing our loader that normally should bypass Defender. So let's go to our development VM. So here we have our loader. We will compile. Okay. Compile. We'll get a main.exe. We will copy this main.exe to our Windows machine. So let's go to our Windows machine. So here I have the real-time protection activated, meaning Defender is activated. And the test.exe should be in the shared folder between all the VMs. So here it is. Let's copy it to our desktop. Here. Okay. And as you can see, unlike what happened with simple exec and the Rubius, test.exe was allowed to be on the machine by Defender. So let's run it. And we got our calculator, as you can see. So the memory was allocated, the shellcode was copied, the protection was changed. Launching thread, even though it returned failed to launch, this is basically it returned a non-nil error, which says, okay, the thread has been launched, but the error is not nil. It says the operation completed successfully. So the thread was launched and we have a calculator and Defender is happy. So let's delete this from our machine. Go. So you may ask yourself, okay, so all of this for just a calculator. So for that, let's take another example to show you that shellcode loaders can be used in various ways. So instead of using the calculator via the exact shellcode of MSF Venom, let's use another MSF Venom payload, which is called the reverse TCP. I think I did it before. So first, let's get the IP of my machine. So here is the IP of my machine on my local network. Okay. I think I did it before, so let's just check my command register. Yeah, so it is. So I'm calling the MSF Venom, but this time the payload is not exec, it's Windows for x64 architecture shell reverse TCP. So this, what it will do, it will be run on the victim machine, and it will open a PowerShell not on the victim machine, but on my machine. This is why it takes my IP, the port it is listening on 444. For example, here it is 444. My IP is here, and the format is raw, like we said before. And let's put it in a file called reverse.tcp shellcode. Okay. We wait sometimes for the payload shellcode to be generated. So now we have reverse TCP shellcode admin. If we go back to our prep, we should still have the prepare. Let's do prepare, and this time the file is not clear shellcode.bin, but it should be reverse TCP shellcode. So loader, yeah, reverse TCP shellcode.bin. Yeah, okay, let's go. It should be prepare. Okay. So this time we got the encrypted shellcode for reverse TCP shellcode.bin. Let's copy that and put it in our encrypted shellcode. I think would be good. So here, instead of the encrypted version of the shellcode that run calc.exe, I have a shellcode that will open a PowerShell ACMD session on my attacker. So as you can see, we have that here. Now what we will do is that we will compile. Let's go back to loader. Go S, go arc compile. Main. So we will copy it later to our Windows machine. But before, because I chose a MSF Venom payload, let's open the MSF console. I think it should run with sudo like always. Okay. Okay. So basically, to get a clean PowerShell, because I used a stage 1, meaning that some interaction should be done with my machine before the PowerShell opens, to send the entire payload and stuff like that. We need to be in a MSF console shell, as you will see, and use a handler. I'll just use. I think I did it before, so it should be in my. Yeah. So you go to MSF console. So if you are on Kali Linux, you should have that by default. You use the exploit multi-handler. Okay. You set the payload to the payload that we put to the payload that we use to generate our shellcode, which is this case. In this case, it is this. We show the option to see what options can be made. The L port is good. We just need to set the listening host to our network interface. So this should be good. And when you press run, what it will do, hopefully, okay. So it will start listening on the port 444 on this IP, which is everything actually. And what will happen now is that when we take our newly generated main.exe that contains the reverse TCP shellcode, we'll take it, we'll call it something Pokemon. Okay. exe. I messed up. So Pokemon.exe should be in my shared folder. Let's copy it. Yeah. I was able to copy it normally without Defender flagging me. And when I run this, some connection should be seen here. So let's test. Next stage. And if you press enter, we have a PowerShell that can be used. Okay, not a PowerShell, CMD. And we can open PowerShell. And we can get all the files and folders of the victim. So that was it for this lecture. Thank you, and please enjoy the last lecture. Hello again, everyone, and welcome to the last lecture of Malware Development with Go, lecture 22. For this last lecture, I'll be giving some notes about threat intelligence. So as we saw before, the loader that we created today is bypassing Windows Defender. Basically, it is bypassing the Windows Defender static analysis meaning the part of the code that will check the exe file if it contains malicious code. If it bypasses Defender today, it does not mean it will bypass Defender forever. Basically because Defender is getting stronger and stronger through the years. Another thing to note is that if someone of you decide to compile the Go code that you will see in the previous courses attachment, and decide to compile and upload it to VirusTotal, VirusTotal will take this malware and share it with the security vendors, meaning the Bitdefender, Microsoft Defender, Avast, etc. And these companies will actually create some rules and IOCs that will be able to say, okay, this file is malicious, and the loader will no longer be able to bypass Defender. Very important thing to note is that Red Teamer and Blue Teamer are both getting stronger with time. More techniques to bypass antiviruses and DDRs are being created each day, and new detection methods are being also developed each day. For example, Defender is starting to do in-memory scan, meaning that the shellcodes that we copied to memory, sometimes Defender will decide to take a snapshot of the memory and scan it to see if malicious code are in it. And if there is malicious code, it will kill your process. This actually means that the team behind Defender is not just doing nothing, but is actually working really hard to improve the product. For example, at the time of this course's publication, Defender recently published a new patch and defense against AMSI bypass. For people who know what AMSI is, showing that really work on Defender is being done behind the scenes. Even though the detection methods are growing, what you have now is the foundation. You have the methodology to use to develop your malware and the principle behind a basic shellcode loader. I really advise you to keep striving to learn more, because knowledge in cybersecurity will never end. So thank you for listening to this course, and I hope you enjoyed and learned as much as possible from it. Thank you.